You wrote a Python code. It should work. You press run and you want to get that green checkmark victory by getting the output that you imagine from your code. But instead, error, red text, or worse, no error, but you don't get the output that you expect from your code. So how do you fight back against this chaos? You don't guess, you don't panic, you need to debug. And today I will show you 5 techniques that every Python programmer needs to know in order to find those bugs and remove them as soon as possible. Let's start with the simplest way to debug your code. Print a statement. You just want to see what's happening inside your code, but variables feel like black boxes. Functions run silently and you don't have any clue what's happening inside them. So you put some print x, for example, to find the x value, and suddenly you find some clues. You can follow the data step by step. Watch it when it transforms to different kind of values and find out exactly at one point everything goes wrong. It's not elegant, of course, it's not complex, but it's pretty effective. Print debugging is one of the fastest way and simplest way to debug your code. Of course, you need also other tools to debug the code because print has limits. Imagine chasing across 200 lines of codes. Print a state everywhere, it's total mess. You want precision. And you want a way to stop the program when the program is already in motion and just pick inside what's happening there. Yet, by default, Python is not pausing for you. It races straight to the failure. You can enter the built-in debugger using PDB. By setting the set trace from the Python debugger, your code halts at the exact point. You step through line by line. You can also check the variables on the fly. It's like freezing to investigate a crime scene. You're no longer guessing, you're interrogating your program. But maybe typing comments into the console feels chunky. You want something smoother, something basically has more visual in it. Yet, without tools, tracing logics through the loops or functions can be really overwhelming. Modern IDEs like Visual Studio Code or PyCharm give you breakpoints. Watch Windows, even variable explorers. You click on the red dot, your program runs, and it pauses exactly at the breakpoint, and you can check everything, including variables and what's the state of functions and what the state of your program. Now debugging feels less like a detective works and more like a smoother experience to go through all the complex logics that you have implemented inside your code. You see everything clearly. But debugging is not always this moment. Sometimes you want to know what happens last night when the server crashed, for example, at 3 a.m. You want a history, a breadcrumb trail of what your program was doing. Print won't cut it. You would down in raw output. So you can switch to the logging module. Instead of random prints, you write logging debug, logging info, logging error, or logging warning. You can choose levels, you can save the logs into the file, and you make everything structured. Now you have a diary of your code life. The bugs, they are already waiting in the logbook. But sometimes the bug is not Python, it's your brain. You want clarity to see your own logic errors. Yet inside your brain, everything is correct. You can't spot the mistake. You wrote it yourself after all. So you explain the code out loud to a colleague, a friend, or even a rubber duck on your desk. This technique is even called rubber duck debugging, as one of the MIT professors explains this technique in the link below in the description. As you speak, your words betray the flaw. You realize, for example, wait, this condition cannot be true. The box falls apart not because something has changed inside the code, but because you did. But what about when you tried everything? You tried prints, breakpoints, even the logs, and you explain the logic to yourself or to a friend. But still the bug slips somehow through everything. In that sense, you want a second brain, not just like hints, like context-aware explanations, some refactor suggestions, or some unit tests that you didn't think to write. You can use AI to debug your code, but AI can be confident and wrong at the same time. It hallucinates, it suggests fixes that sound right, yet crash on contact with reality. Therefore, you treat the AI like a sharp tool. It is not a magic wand. You feed it exactly what it needs. The minimum reproducible snippet, the exact traceback, the expected versus actual behavior, and the tiny test that fails. It proposes a fix and a reason, and then you can run the test and it passes. You integrate safely. The bug doesn't gone, it proved it's gone. You began with broken code and rising frustrations. You want to always to fix your bugs as soon as possible. Endless unknowns, the invisible mistakes, they are all stood in front of you, but with different debugging techniques. And yes, even with rubber duck, you have tools and perspective to resolve them. So next time where your Python code breaks, you know exactly how to fight back. Because debugging is not waste of time and it's not punishment. It's the power that enables you to go through the hardest challenges that you have with your code. Until the next video, good morning, good afternoon, and good evening. Bye. you.